Have you ever looked at your phone and it instantly recognizes your face? Or scrolled through photos and it knows exactly who's in them? It kind of feels like magic, doesn't it? But it's not. And we're about to pull back the curtain and see exactly how these machines actually learn to think. So, if you wanted to build a machine that learns, where would you even start? Well, the original pioneers looked right at the best learning computer on the planet, the human brain. Turns out the blueprint for AI, it's biological. Deep inside our brain, we have billions of these things, neurons. You can think of each one as a tiny little gatekeeper. It gets all these signals coming in through its inputs, the dendrites, and it basically asks, is this signal important enough? If the answer is yes, then bam, it fires its own message down its output, the axon. It's a simple little go or no-go decision, happening billions of times a second. So what computer scientists did was brilliant. They looked at that beautiful, complicated biological neuron on the left, and they stripped it down to its core idea. They created a clean, simple mathematical version of it, the one you see on the right. The basic job is the same. Take in some signals, figure out how important they are, and then produce a single output. This was the birth of the artificial neuron. Okay, so we have one of these artificial neurons. Big deal, right? What kind of single one of these things actually do? Well, it turns out it's a really simple but also a really powerful little decision maker. At the end of the day, an artificial neuron is really just math. It's a function. It takes in some numbers, some data, and it spits out a single answer. That's it. But this little piece of math is the fundamental Lego brick for building a massive AI brain. All right, let's make this real. Imagine we run a clothing store, and we want to predict if a new t-shirt is going to be a huge hit. And let's say the only thing we know about it is the price. Can just one neuron help us out? You bet it can. The neuron takes in the price as its input. Then, inside, it multiplies that price by a weight, which is just a number that represents how important price is. After doing the math, it makes a simple call, yes or no. Is this shirt likely to be a top seller? But what happens when things get more complicated? Because here's the secret. The real power, the thing that feels like magic, it doesn't come from one lonely neuron. It comes from connecting thousands, sometimes millions, of them together in layers, where each layer builds on what the one before it figured out. Okay, back to our t-shirt. In the real world, price isn't the only thing that matters, right? You've got shipping costs, marketing spend, the quality of the material. A single neuron trying to juggle all of that would just get lost. It's too much information. This is where it gets really clever. We add a hidden layer of neurons. Think of them as middle managers. So instead of looking at raw data, one neuron might look at the price and shipping cost and learn the concept of affordability. Another looks at the marketing budget and figures out awareness. And a third might look at the material and the price to get a sense of perceived quality. And this right here is the absolute key. We don't tell the network to look for affordability. We don't program that in. It discovers that affordability is a useful concept all by itself, just by looking at the data. The network is literally an automatic factory for learning important features about the world. Okay, I can see how that would work for t-shirts, but how does that same idea scale up to do something as incredibly complicated as recognizing a human face in a photograph? Well, we're about to see this layering idea in action. This is, step by step, how an AI literally learns to see. So when you feed the network a picture, it doesn't see a face. It just sees a grid of pixels. The very first hidden layer of neurons has a super simple job. It learns to find the most basic things, like little diagonal lines, horizontal edges, and simple gradients from light to dark. Each neuron becomes a tiny specialist at spotting just one of these things. Now, the next layer doesn't get pixels. It gets the output from that first layer, basically a map of all the edges. Its neurons then learn to combine those edges into more complex shapes. This is where it starts to see things that we would recognize, like the curve of an eyebrow, the line of a nose, or the shape of a mouth. Then, the deeper layers take those parts, the eyes, noses, and mouths, and they learn how they're all supposed to be arranged. These neurons learn the general pattern of a face. And at this final stage, it's not just seeing a bunch of parts anymore. It's seeing the whole thing. It is recognizing a face. Let's just pause on that for a second. What we just saw is the absolute genius of deep learning. It's an automatic factory that builds understanding from scratch, using nothing but raw data.
I mean, think about it. No programmer ever sat down and wrote code that said an eye is two curves with a circle in the middle. The network discovered what an eye is, what a nose is, and what a face is, all on its own, just by looking at thousands of pictures. It literally taught itself how to see.
Now get this. On the left, those are the features the network learned were important for recognizing faces. But on the right, that's what the exact same network learned when it was trained on pictures of cars instead. It didn't find eyes and noses, it found wheels, windows, and headlights. The network is completely adaptable. And that really says it all. The network structure is a general-purpose learning machine. Its expertise comes entirely from the data you show it. It's basically a blank slate that can become an expert in almost anything, just by observing. So, if these networks can teach themselves to see and recognize really complex patterns in our world without us having to explicitly program them, it leaves you with a pretty massive question, doesn't it? What will they learn to do next?